Alright, hackers and hackerettes, welcome back. I'm gonna assume that you're watching these in the playlist and you're actually watching these in sequence. Please do if you're not, because you're missing a lot of context. Let's get into virtualization basics in our computer fundamentals. In previous rooms, you learned what the components of a computer are and how they communicate with each other. In this room, you will learn how companies have optimized these computer components to reduce costs and build flexible, scalable systems that power the modern internet. Virtualization. Have you ever considered how expensive and inefficient it would be if every piece of software or every website required its own physical server? Virtualization was created to solve exactly this problem. Your manager asked for help on improving the hardware utilization of a computer that hosts a website. Let's explore the concept of virtualization and help your manager. Why managing applications, blah, 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 inside a computer system, client server. These are actually not coming soon. This is actually what we have been working on in this playlist. So we already covered these. Before the concept of virtualization, the rule of thumb in IT was one server equals one application. In the early days, digital services were run on physical machines, and each machine typically had a single clear purpose, such as hosting a website or storing data. As businesses added more services, they naturally increased the number of physical servers, and the one job per box approach became the standard for building reliable systems. This meant that if a company wanted to run a website, a database, an email service, and an internal app, they would need separate physical servers for each one. The problems were obvious: high cost. Buying multiple physical servers is expensive, not just the hardware, but also electricity, cooling, maintenance, and data center space. Low utilization. Most applications don't use the server's full capacity. Many servers stayed at 5 to 20% usage, wasting CPU, memory, and storage resources. Slow deployment. Setting up new physical servers could take days or weeks. Hard to scale. If an application suddenly needed more resources, you often had to buy yet another server. In short, companies were paying a lot for hardware that wasn't being fully utilized. The need for sharing hardware safely and efficiently. Virtualization introduced a new idea. What if multiple applications could share the same physical server safely? A virtualization layer called the hypervisor was introduced to act as a referee between lab machines and allow each virtual computer to behave independently like a physical computer. The building analogy. Imagine if one single person lives alone in an entire 10-floor building. The person uses only one floor but must maintain the entire building: electricity, cleaning, water, and security. Most of the building stays empty and wasted. It's expensive, inefficient, and unnecessary for his needs. Imagine dividing the building into separate apartments. Each apartment has its own door, walls, kitchen, and privacy. Different people can live independently without bothering each other. They all share the building's main structure: electricity, water, and elevators, making it cheaper and more efficient for everybody. This is a very good analogy, by the way. This is virtualization. The building equals the physical server, the apartments equals lab machines, the tenants, applications, or operating systems, and the building manager, the hypervisor, the software that divides the building safely. Each virtual computer, known as a lab machine or VM, virtual machine, acts as an independent system with its own operating system, apps, and settings, even though they all share the same physical hardware underneath. So essentially, when I told you that you're going to need to install like Kali Linux as a virtual machine, Kali Linux is its own operating system, just like Windows, just like Ubuntu, just like Mac OS. It is its own standalone operating system. But since we don't need to install it like on the metal, we don't need to install it instead of Windows or next to Windows. We can actually just run it in a virtual machine, which is going to run it exactly as if it was running on a real computer, but it's gonna be convenient and you don't have to completely manage Kali Linux as if it was on a real machine, or like on your basically what we call the host machine. So it's running as a guest, as a virtual machine on your host machine, which is like your Windows or your Mac or even your Linux. So you could run a Linux virtual machine inside a Linux host machine, which is completely fine. And actually, I would argue it gives you more benefits in case you are doing like you're just testing settings and you're doing weird stuff in the OS. You're like playing with the virtual machine that you could completely destroy it. Maybe someone told you run rm tech rf and slash, and then yeah. So you just remove the entire operating system, like literally. So anyway, having a VM, you could essentially just scrap or even take snapshots and then revert back to these snapshots at any time, is very, very good. And you don't want to not use something like that, especially in our Kali Linux and hacking use case. Anyway, what does virtualization enable multiple applications to share? They could share everything, essentially. Like, really, they could just share everything. But the answer that they're looking for the answer that they're looking for, physical server probably is what they're looking for. Yeah. What is the name of the software that manages resources for each lab? It's called Hypervisor. Let's talk at Hypervisor or virtualization components. Hypervisor. A hypervisor is the core technology behind virtualization. It is the software that creates and manages lab machines. It is a special piece of software that divides a physical computer into multiple virtual ones, gives each lab machine its own share of CPU, memory, and storage, keeps everything isolated and safe, manages the life cycle of lab machines: start, stop, pause, clone, delete, so on. Hypervisors have two main types of implementation. Can run directly on the physical hardware, making them fast, efficient, and ideal for servers and professional environments. Hypervisors run within an existing operating system, making them easier to install and ideal for learning, testing, or small setups. So, for example, like what we always do is VirtualBox or Hyper-V on Windows and stuff like that. Below is a table showing which use case is best suited to each hypervisor type. And test malicious files. Yeah, exactly. This is one of the main reasons actually that I used, well, back in the day at least, I used to create like Windows VMs, and then I would install malware just to study what they do to computers, just out of curiosity. Like, I know I downloaded a virus, but I'm not going to run it on my main computer. So I would just copy it to or like move it, not just copy it. I would move it to a VM and then run it just to see what it does, essentially. And with that, I gained a lot of knowledge into how malwares like infect Windows computers and how they make themselves like start with your computer without you even realizing it, and how they can even spread to networks and attach themselves to emails and just do all kinds of crazy stuff. And all of that I did safely in a VM. So whenever I just got bored, I would delete that VM or revert it back to an older snapshot and just use that. So production server type 1, which is the runs directly on the physical database directly. Software testing, Kali Linux, which we're going to be using together a lot, and then data center, it runs on the server. Okay, so lab machines. A lab machine or a VM is a virtual computer created by the hypervisor. Even though it's virtual, it behaves as a real machine. Yeah, has its own virtual CPU, RAM, storage, and network. It can run any operating system, Windows, Linux, etc. It's completely isolated from other VMs. This means if one VM breaks, the other continue to work. You can deploy VMs on your own computer using tools such as Oracle VirtualBox and VMware Workstation. This type of software acts as a Type 2 hypervisor and lets you run multiple operating systems such as Windows, Linux, and macOS. Since you have learned what a hypervisor and VM are, let's take some examples where you might need them. You need to work on a different OS like Kali Linux, but you can't fully buy, or you cannot buy another whole system. So install a hypervisor and install Kali Linux VM on it. Perfect use case. You want to test whether a file is malicious, so you set up an isolated lab machine to protect your main computer from being infected. Exactly. Since everything is virtual, the virus or the malware does not have a way for, it does not have a way to escape the VM. There are some malware that claim they can escape virtual machines and can escape honeypots. I'm not going to explain what a honeypot is, but essentially it's like a trap set for malicious software and hackers in order to waste their time or capture them, like make them do mistakes and under full monitoring without real consequence. Anyway, just Google the term honeypot. But essentially there are a lot of malware that can claim they can escape virtual machines. From my limited experience in malware analysis, that was not always true. it did try to infect, like it does try to do that, but usually it just cannot escape the virtualization set by, at least my tests were on VirtualBox. I don't know if other software would matter or would differ. I don't think so, but I'm not the expert to judge this. But overall, you're pretty much super safe using a VM. Containers, the rooms inside the apartment. A container is a lightweight, isolated environment that runs a single application and all the necessary components to support it. Instead of bringing a whole separate operating system, a container borrows the core of the existing system by running on the kernel. If you don't know what this is referring to Docker, which is one of the most important, and it basically revolutionized how applications deploy and how to set up like dev environments on multiple machines that are going to run the exact same way. Because containers share this kernel, they start quickly and use fewer resources than full lab machines. But it also means they must match the host system type. For example, you can't run a Windows container on a Linux machine. Containers behave like small self-contained spaces because they package the application, its dependencies, libraries, tools, versions. They share the host's operating system, so they start almost instantly. They remain isolated from each other. A misbehaving container doesn't affect the other. They run constantly or consistently on any machine, making them perfect for development, testing, and scalable deployments. The easiest way to deploy containers to use a VM is using Docker. Docker is an open source platform or software platform that simplifies the process of building, deploying, and running application using containerization. The image below illustrates the relationship. Then you can see we have a physical server, hypervisor, virtual machine A, B, container A, and container B. In summary, VMs provide a full apartment with maximum separation, blah, blah, blah. Okay. Suppose a user wants to deploy a study lab on their machine to practice some exercises for a cybersecurity certification. Which type of hypervisor? They'll use a type 2. A company wants to host multiple small applications in the same lab. What should they use? I don't know, I don't know what the specific word they're looking for here. Suppose a company wants to host multiple small applications in the same lab machine. Containers? Is that what they're looking for? Yeah. All right, task 4, managing virtual machines. After learning about virtualization, you were hired to be responsible for the virtual environment for Autogallo, a company that has recently started using lab machines. In this company, they use an application called Virtualization Manager. This application provides a clear view of the overall status. Your manager is, okay, let's just view the site and get into it. Let's just jump into it. So the mail server has an error. So we just restart it. It's just running like that, easy. So then we fixed it. After running, it appears to be working correctly with no errors. Okay. Creating a lab machine. Let's create a VM. Marketing VM. Cores 4, 8, and then 100. Create VM. I'm just following what they're saying right here. Marketing VM just started. Analyzing hardware usage. Oh, we have a bunch of stuff. Okay, now answer the phone. What is the name of the lab machine that has been running for the longest time? Let's order by uptime, 3 weeks and 2 days. Monitoring sys. Lab machine uses the biggest amount of memory. So you just go to memory and then order by that. 32 gigs DB. The database is always a memory killer. How many VMs are in the running state after you solve the issue on null server? Where's the state? Oh, there we go. 3, 4, 5, 6, 7, 8, 9. Was I supposed to turn off one? Oh, was I not Was I not supposed to run this? So it's supposed to be 8. Are in the running state after you solve the mail server. 1, 2, 3, 4, 5, 6, 7, 8. And then if we run the marketing VM, that is 9. Alright, I need to refresh this. I don't know if it's broken or not. Oh, it's 8. Correct answer. Okay, so I'm not supposed to run the marketing, whatever. Well, anyway, what is the name? Oh, shit, I need to go back. I did not mean to close that. I just clicked. What is the name of the physical machine that is hosting most of the VMs? Name of the physical machine. I think it's HV Broad 2. Okay, so the conclusion is virtualization, hypervisor, lab machine, container images, network ports. Through hands-on practice, you experience how virtualization simplifies and accelerates application deployment, providing fast and secure way. Present the fundamental. Okay, I'm ready to cloud. So in the next video, we are going to the cloud together. And we're going to do cloud computing fundamentals, which I myself find very interesting because I actually did not study cloud computing fundamentals the exact way that I studied everything else almost. So going through this and understanding what cloud computing is, and we'll be experiencing it together, is going to be cool. So stay tuned for that. Thank you for watching. Let me know in the comments below whether you like or dislike these videos. Any constructive criticism is always welcome. Like, subscribe, and all of that cool stuff. Thank you for watching, and I'll see you in the next one. See ya.